Have you ever wondered how an electric car works? It's a question that's been on the minds of many as we witness the surge of these sleek, silent machines on our roads. Electric vehicles, or EVs as they're commonly known, aren't just a trend. They represent a significant shift in the automotive industry, a move towards sustainable and efficient transportation. At first glance, an electric car might seem like any other car. It has wheels, seats, a steering wheel, all the basics. But under the hood, it's a different story. The heart of an electric car is its battery, an energy storage device that powers the vehicle. Then there's the electric motor, which converts electrical energy into mechanical power. The controller, the brain of the operation, manages the power flow between the battery and the motor. And finally, there's the charging system, the equivalent of a fuel station for an electric car. Not so different from a conventional car, right? But wait until you hear about how these parts work. First up, the power source, the battery. Now, this isn't your typical AA battery you'd find in a TV remote. No, these are high-capacity, rechargeable powerhouses designed to store and deliver the energy needed to propel your car forward. Think of the battery as the fuel tank of an electric car. In conventional vehicles, you have a tank filled with gasoline, which is burned in the engine to produce power. But in an electric car, the battery replaces this fuel tank. Instead of storing gasoline, it stores electricity, a form of energy that's cleaner and more sustainable. So how does this work? Well, it all starts with charging. Just like you'd fill up a gasoline tank, you charge an electric car's battery. This energy is stored until it's needed to power the motor. But instead of a gas pump, you'd use a charging station or even a special outlet at home. Now you might be thinking, okay, so the battery stores the energy, but how does it actually power the car? Great question. The energy stored in the battery is released as electrical current. This current is sent to the motor, which then transforms it into mechanical energy. This mechanical energy is what actually moves the car. But batteries aren't just plug and play. They are complex pieces of technology, carefully engineered to safely store and deliver large amounts of energy. They need to be efficient, reliable, and durable, able to withstand the rigors of daily use and last for many years. And what's more, they also play a crucial role in the overall performance of the car. Things like acceleration, range, and charging speed, all heavily influenced by the design and capabilities of the battery. The battery, simple in concept yet complex in design, is what fuels our journey. Now let's turn to the heart of the car, the electric motor. This ingenious piece of machinery is what takes the stored power from the battery and turns it into the kinetic energy that propels your car forward. But how does it do this? Well, it all comes down to the principles of electromagnetism. An electric current from the battery is sent into the motor, creating a magnetic field. This field interacts with magnets in the motor, causing them to spin. This spinning motion is then transferred to the wheels of the car, and voila, you're on the move. But that's not all. The electric motor is also responsible for a clever trick that helps to recharge the battery. This is known as regenerative braking. When you apply the brakes in an electric car, the motor goes into reverse mode. Instead of using electricity to create motion, it uses the motion of the slowing car to generate electricity. This energy is then fed back into the battery, giving it a little top-up every time you slow down or stop. So not only does the electric motor use energy efficiently to get you from A to B, it also helps to reclaim some of that energy in the process. It's a beautiful example of how engineering can mimic the natural world, where nothing is wasted and everything serves multiple purposes. But of course, the electric motor isn't acting alone. It's part of a team, working in harmony with the other components of the electric car to give you a smooth, efficient, and environmentally friendly ride. The electric motor, a marvel of modern engineering, propels us forward with the power of electricity. It's a key player in the revolution of transportation, and its role is only set to grow as we continue to strive for a cleaner, greener future. But who's the conductor of this orchestra? The controller. Now, this isn't your typical video game controller or TV remote, but rather the unassuming maestro of the electric vehicle. Just as a symphony conductor dictates the tempo and dynamics of a musical piece, the controller in an electric car commands the flow of electrical energy. Imagine the controller as the brain of the car. It's constantly making decisions, adjusting the amount of electricity that goes into the motor based on the driver's actions. When you push the accelerator, the controller says, "All right, let's give this motor more juice." When you ease off, it dials back the power. It's a continuous dance between the driver's foot and the controller's logic. But it's not just about power, it's about efficiency. The controller helps manage energy in a way that maximizes the car's performance while minimizing its consumption of electricity. It's like a savvy shopper always looking for the best deal. The controller also has a say in regenerative braking, a feature that's unique to electric vehicles. When you hit the brakes, instead of wasting that energy as heat like in traditional cars, the controller directs the motor to work in reverse, turning kinetic energy back into electrical energy, which is then stored in the battery for later use. It's a rather clever way of squeezing every last bit of energy out of the system. And let's not forget about the role of the controller in ensuring the safety of the vehicle. It constantly monitors the state of the battery and motor, preventing any potential overloads or overheating. It's like a vigilant guardian, always on the lookout for any potential threats. So next time you're cruising in your electric car, remember the controller. It might be out of sight, but it's always hard at work, making sure your ride is smooth, efficient, and safe. Without it, well, you'd just be sitting in a very expensive paperweight. The controller, an unseen hero, ensures everything runs smoothly. Last but not least, the charging system. Just as with traditional vehicles, an electric car requires a fueling system. But instead of gasoline or diesel, we're talking about electricity. And instead of fuel stations, we have charging stations. Now there are different types of charging systems for electric vehicles, each with its own pros and cons. The three most common types are level 1, level 2, and DC fast charging. Let's break down how each one works. Level 1 charging is the most basic type. It involves plugging your electric vehicle into a standard household outlet. Although it's convenient because you can do it anywhere with an outlet, it's also the slowest method. It can take anywhere from 8 to 24 hours to fully charge a vehicle, depending on the car's battery capacity. Then, there's level 2 charging, which uses a 240-volt system similar to what powers your clothes dryer or oven. This method is faster than level 1, typically charging a car in 3 to 8 hours. It's a popular choice for home charging stations and is also commonly found at public charging stations. Finally, there's DC fast charging, the speediest option of them all. These stations convert AC power to DC within the charging station before it's sent to your car, bypassing the vehicle's onboard charger and saving time. A DC fast charging station can charge a depleted battery to 80% in just 20 to 30 minutes. However, these stations are more expensive to install and run, making them less common than level 1 and 2 stations. So you see, charging stations are the equivalent of fuel stations for electric vehicles. They provide the energy needed to keep your electric vehicle moving, making them a crucial component of any electric car's ecosystem. The charging system, our lifeline for long journeys, keeps our electric car running. So, that's how an electric car works. From the battery, the heart of the machine storing energy like a reservoir, to the electric motor, which uses this energy to generate power and propel the car forward. We've also delved into the controller, the brain of the operation, expertly regulating energy flow from the battery to the motor. And lastly, the charging system, the fuel station in your very own home, replenishing the battery's energy to keep your car running. The simplicity and efficiency of electric cars are truly unparalleled. They eliminate the need for complex mechanical parts and the use of fossil fuels, making them an eco-friendly option. These vehicles, with their remarkable blend of technology and sustainability, are not just a novelty but a significant shift towards a more sustainable future. Electric cars, a testament to human innovation, are driving us into a greener future.